Hey guys, hope you're doing well. Today we'll be talking about the divisibility rules for 5, 6, 7, and 8. Let's start with the divisibility rule for 5. Any number is divisible by 5 if the last digit or the unit digit is either 0 or 5. So if I take the number, let's say 125. 125. According to our rule here, it does end either 0 or 5. It ends with a 5. And to show that 125 is actually divisible by 5, I can just show you that. 125 divided by 5. This goes 2, leaving 2 here. 25 divided by 5 is 5, which shows us that this is our quotient with no remainder. So this example proves that any number which is divisible by 5 either ends with a 0 or 5. Now let's try a number that ends with a 0. Let's take 100. Now, according to our rule, this number should be divisible by 5 because it ends with a 0 right here. So let's check that out if it's true. 100 divided by 5 is 20, with a remainder being 0. So these two examples prove that this divisibility rule is true. But let me show you where it doesn't work. Let's take a number, say 552. Now, according to our divisibility rule, this should not be divisible by 5. And let's check it out. 552 divided by 5. Well, that goes 1, 1, 0, giving us a remainder of 2, which proves that this number is not divisible by 5 because it does not end with either 0 or 5. But these numbers right here, they are divisible by 5 because they end with a 0 or a 5. Moving on to the divisibility rule of 6. My bad. There you go. So, any number is divisible by 6 if the number itself is either even and divisible by 5. I shouldn't have said either because it really isn't either or, it's and, which means in this case that it has to be, my bad, 1 minute, it has to be even and divisible by 3. If it's not both, then it's not divisible by 6. And let's try a few examples for this. If I take the number 72, let's check first whether it's even. And the number is even when it ends, the last digit or the unit digit is an even number. And so in this case, it is even. Another way to check, if you're not really sure what even is, you can always use the divisibility the divisibility rule of 2 and divide it by 2 to see whether it divides by 2, because any number that's divisible by 2 will be even. And now we're going to check out whether it's divisible by 3. But let me just say that that was a terrible arrow. Yes, it's even. So that's one tick. Now we have to check whether it's divisible by 3 or not. And as shown in my previous video, I show how to do the divisibility rule of 3. And so how that works is we have to add all the digits of the number. So 7 plus 2 is equal to 9, and see whether this number is divisible by 3. So 9 divided by 3 is 3, which gives us no remainder. So we can also say that yes, this number is divisible by 3. And now that we have both of our statements satisfied, we can conclude that 72 is divisible by 6. Let's take another example. Let's say 32. Once again, we have to check whether this satisfies both statements right here. And 32 is even. Once again, you can see that whether the last digit is even or not. So yes, it's even. So now that we know it's even, now we have to check whether it's divisible by 3. Doing the same using divisibility rule of 3. So 3 plus 2 gives us 5. And 5 divided by 3 leaves us with the remainder. Our quotient would be 1, and our remainder would be 2. So that shows us that this is not divisible by 3. And well, even though we have one part that satisfies, the other part does not. And so we can conclude that 32 is not divisible by 6. And if you want to check that, let's check that on the side right here. 32 divided by 6. Now, 6 times 5 is 30. So our quotient would be 5, sorry. And remainder would be 2. And because we have a remainder, that shows that 32 is not divisible by 6. Moving on to the divisibility rule of 7. Oops. To figure out whether any number is divisible by 7, you have to double the last digit and subtract this number from other remaining digits. Now that may sound a bit confusing, and for me personally, it was confusing. I never learned the divisibility rule of 7 until 2 years ago. But let's try it together. Let's take the number 343. Now, let's just follow this divisibility rule. You double the last digit. So let's do that. The last digit is 3. Doubling it would be 3 times 2, which gives us 6. And subtract this number from the other remaining digits. The other remaining digits is 34. So we're going to be doing, sorry, that was a terrible circle, 34. So we'll be doing 34 minus 6, which gives us 28. Now compared to 343, 28 is so much easier to check whether it's divisible by 7. So 28 divided by 7 gives us 4 with no remainder. And that proves that 343 is divisible. Oh, sorry. It is divisible by 7. Now let's try out another example. Let's take um 132. Once again, let's just follow the rule. So double the last digit. In this case, our last digit is 2. 2 times 2 is 4. And subtract it from the other remaining digits, which would be 13 minus 4, which gives us 9. 9 divided by 7 gives us a quotient of 1 with a remainder of 2. That shows us that 132 is not divisible by 7, and let's double check that. 132 divided by 7. Well, it goes 1, with leaving us a remainder of 6. So 62 divided by 7, that would go to 8, leaving us a remainder of 6. So that once again proves that 132 is not divisible by 7. Lastly, let's do the divisibility rule for 8. Any number is divisible by 8 if the last 3 digits are divisible by 8. It's kind of similar to 4, but in this case it's the last 3 digits and they have to be divisible by 8. Let's take an example of, so our example here is 104. So our last 3 digits have to be divisible by 8. Well, in this case, we just have to divide the number by 8, and we get 13 with no remainder. That shows that it's divisible by 8. But let me take a larger number where it gets a bit more confusing. Such as, let's take 1360. So according to the rule, we have to check whether the last 3 digits are divisible by 8. And let's do that. Last 3 digits in this number is 360. Is 360 divided by 8 divisible by 8? Let's check that. 360 divided by 8 gives us, that goes to 4, which is 32, giving 3. So 45 with the remainder of 0, which shows that this number is divisible by 8. If you want to prove that, you can always check it by dividing it by 8. 1360 divided by 8 gives us 170 with the remainder of 0. Now let's try another example. Let's take 1802. So we have to check whether the last 3 digits are divisible by 8. Let's do that together. 802 divided by 8. 100. And our remainder is 2. So that proves that, oops, I erased the 1. 1802 is not divisible by 8. If you want to check that out, 1802 divided by 8, that goes 2, which leaves us a remainder of 2, so 4. Oops, I'm so sorry, I didn't mean to write 4, it's supposed to be 2. And then that goes So that would be, our quotient would be 225 with the remainder of 2, which once again proves that this is not divisible by 8. Thanks for watching this lesson. If you like this video, please subscribe to my channel, Algebra Star, or visit algebrastar.com. Once again, thanks, and stay safe.